Hello dear students, welcome once again to the NEET 10, a game changer program by Sri Chaitanya. Here in these sessions we are going to learn the concepts through the numerical solving. As you had been seeing, half of the sessions are over and we have to go halfway through, and let's learn some more interesting concepts related to the chemistry through these discussions. So not only we will just solve the questions, we will also understand how can you attempt these questions without any external assistance, because this is the time in the coming week, not even a week, so you're going to write your ultimate examination, that is NEET UG 2024. Now when you are about to write the examinations, you have to polish all your skills, especially in the attempt of a particular question. So you have to increase your familiarity index. That means when you see a question, before you attempt, you need to ascertain whether you could attempt that or not. It is the fundamental aspect of preparation. Now at this junction, you have to improve your familiarity index. What I mean to say that when you are given a question paper, instead of just getting over a particular question, you need to see whether you can solve it or not. That means whether the question is from the familiar topic or not. For example, if there is a question asked from stoichiometry and you are not thorough in stoichiometry, then your familiarity index is low. If the question is from atomic structure and you could solve it, the familiarity index is high. So ensure that you attempt as many as possible by assessing the familiarity index initially. And there, while assessing the familiarity index, my suggestion to you is to see what is asked in the question. That means instead of reading the question from the front, I suggest you to see what is asked in the question. For example, if the question is about solubility product, you know that solubility is equal to S, then solubility product can be calculated so easily. What is the pH of solution? Which one is more acidic? What is the stability of carbocation? That means if you strike straight away on what is asked, there are chances that you will not waste much of your time. So with this advice, let me move ahead in my discussion and welcome you all once again, and hope the session goes well as was going on for the last 5 sessions, and you know the timings, isn't it? I'm pretty sure that you are following. Yeah, so alright, Shreyas, welcome you all once again to my class, buddies. Alright, now let's start with a question in ionic equilibrium. Most of the students are scared of ionic equilibrium, but if you see the last 5 years trends, the question which is asked from ionic equilibrium is easier than what you expect. So please don't give up, see the question, try to understand. You are given a salt which is insoluble in water. How would I know that it is insoluble? You can see the solubility is not 100%. Alright. So insoluble or sparingly soluble salt, dissociation is partial, isn't it? You will be getting calcium plus 2 and OH minus, isn't it? Now this is the salt dissociates. If I assume that the solubility of the salt is S, that means S mole per liter of calcium hydroxide is dissolved in water, how much of hydroxide ion will form? 2S, because you know that 1 mole of the salt is giving rise to 2 moles of the hydroxide. You guys got the answer also, Anish? We have been missing you, buddy. Now you see we are given the value of solubility as, you can see, root over 3, and you know how we write Ksp, which is equal to concentration of calcium ion into concentration of OH minus whole square. Now when you substitute the given, okay, buddy, concentrate values, you can see this is root 3 and this is root 3 whole square, isn't it? So you can simply calculate and get your answer. You can see the next question seems to be also from the ionic equilibrium, right? But there are the question looks to be incomplete. So sorry about that. Okay. Now Anish, Let's concentrate on this question. Some part of this question is missing, and let me explain what you call the concept related to what you call salt hydrolysis and buffer by taking this question as a reference. Though it is incomplete, you can see the mixture which can act as a basic buffer is. So something is missing definitely over there. I don't want to get into that. Suppose I am given this mixture, you have to tell me it can act as a buffer or not. Can anyone answer this question? Can it act as a buffer? If I take equimolar mixture of the weak acid and the strong base, can it act like a buffer? Yes, Anish, may I know the reason why? Could you please tell me? Enduko cheptava? You see, when the reaction takes place between these two, full salt is produced. Any other better terminology that you can use? You know that when these two react, you will be getting what? So let me explain you the cases where it can act as a buffer. Listen now. You have got how many millimole of this? You need to convert this into millimole when you are mixing something. Molarity into volume in milliliter. Alright. So this is 10 millimole of sodium hydroxide, and you can see molarity into volume in milliliter. 10 millimole of acetic acid is taken and mixed. That means when the equivalence of acetic acid is equal to equivalence of NaOH, that means you have arrived at the end point, isn't it? Yes, no weak acid. Brilliant, that's better. So you can see here that at the end point, this constitutes the end point of the reaction, because number of millimoles N1V1 is equal to N2V2. You can see these two values are same. These two values are same. The values are same means neither NaOH is left out nor acetic acid is left out. That means your solution does not have any weak acid. Your solution does not have any weak acid. You know that buffer is formed. Buffer is formed when weak acid is present along with its salt with a strong base. So then there is no weak acid, no buffer. So remember, at the end point of a titration, you cannot anticipate the formation of any buffer. Alright, that's good. Okay, forget about the question, concentrate on the concept. Now listen to this. The process is spontaneous at what temperature is asked. Listen. Now when we talk about the spontaneity, you know that delta G will tell you the story. Remember, the spontaneity criteria starts from equal to 0 for delta G. From equilibrium, the spontaneity starts. If you are pushing it in the forward direction, it is spontaneous in the forward direction. If you are pushing in the backward direction, it is backward. Yes, looks to be. So delta G equal to 0 means delta H minus T delta S equal to 0. So delta H is equal to T delta S. So temperature is equal to delta H by delta S. So remember, these type of questions are very frequently asked. Alright. Come on, concentrate. Delta H value is minus 30 and delta S is also negative, that gets cancelled. So I am going to substitute. So this value is 30, but you can see it is in kilojoule. 30,000 joule divided by delta S value is 75. So this is the temperature that you need to substitute. Brilliant. Come on, focus. So right answer, you got 270 for this. I hope you understood what you say. What is Nessler reagent? Come on, type it. Very frequently asked. Yasu. Shreyas, come on. What is Nessler reagent? Come on, anticipating answer from you. K2 Hg I4, isn't it? You need to know from where it is obtained, right? Come on. It is obtained when Ki reacts with HgI2, right? And you can see it has the potassium, mercury and iodine, but it does not have the oxygen. That's a brilliant answer, buddy. Yasu. Mercury is the key element of the compound, so you can't miss it, right? Now let me explain you the structures. How do we predict the structures, right? Now when you are given a compound, take the central atom, central atom is the one which has more valency. Remember this. What is central atom? Central atom has more valency. Let me give you a very easy method to predict this. Central atom is not the one which lies at the center. Central atom has more covalency or valency. Point number one, we need to understand that central atom has more valency. So these encircled atoms are the central atoms. And after that you are going to find out the X value. Remember, there is a formula for this, easy method. Let me explain this to you so that you can work out any example. X of central atom, valence electrons, alright, plus hydrogens and halogens. Easy formula and you will be really happy. Valence electrons plus hydrogens and halogens minus overall charge by 2. You follow this easy formula, buddies. You can see xenon has how many valence electrons? 8th group, no? 8. Plus how many halogens attached? 4. There is no charge present on it. So X value of this compound is 6. Because this formula will be helpful in predicting the hybridization, geometry, everything, believe me. This sulfur valence electrons are 6 plus halogens attached are 4 by 2. Nitrogen valence electrons, you know that it belongs to 5th group, plus hydrogens attached, you can see, minus charge is there by 2, which is equal to 4. This is bromine valence electrons are group number 7, plus halogens attached to it are 3 by 2, 5. Now you see, after predicting the X value, listen, you can predict the hybridization. This is another advantage of this thing, right? Hybridization. Let me pick this color, right? Hybridization. 6 means sp3d2. 5 means, I am writing not for that, I am writing for this. 5 means sp3d. 4 means sp3. 5 means sp3d. So this is how we predict the hybridization, the easiest way to predict the hybridization. And after that, how to predict number of lone pairs? See how many advantages are there. So you can see you got X value as 6, isn't it? Now you got the X value as 6 minus number of atoms attached to that is 4. So number of lone pairs would be 2, because lone pairs are also asked. So this formula will not only tell you the hybridization but also will tell you the number of lone pairs. Let me take one simple formula to predict many things, right? All in one formula. Listen. So 6 you got, and atoms attached are 4, so 2 lone pairs are present. 5 minus atoms are attached is 4, that is number of lone pairs are 1. 4 minus number of atoms attached ammonium 4, that is lone pair 0. And over here number of atoms attached are 3, so lone pairs are 2. So you got number of lone pair by using this formula. After predicting the lone pairs, you have to predict the geometry. Now listen all of you, please. Important one, please concentrate. You can see sp3d2 is the hybridization for XeF4. sp3d2, the geometry is octahedral. sp3d, the geometry is trigonal bipyramidal. sp3, the geometry is tetrahedral, and last one is sp3d, the geometry is trigonal bipyramidal. So based on the hybridization you will draw it. Remember this, based on the hybridization you will draw the geometry, and after that you will allot the number of lone pairs. You can see how many lone pairs are here, 2. You can see I am keeping 1 here. You can keep wherever. On octahedral position, all the positions are same, 90-degree angle, so you can place wherever you want. After that you see, that means this is the geometry of XeF4, which is called as, with respect to only the atoms, not lone pair, is called as square planar, isn't it? So XeF4 is square planar. I am writing here the geometries square planar. We got it. Next, SF4. You can see that in SF4 the number of lone pairs are 1. I'll always keep the lone pairs on the equatorial position. Sulfur at the center, 4 fluorines are there. This is called distorted tetrahedral or seesaw. Alright, so SF4 is distorted tetrahedral or seesaw. You got the geometry of SF4 as seesaw. And after that, ammonium is tetrahedral for the reason that there are no lone pairs. This is nothing but ammonium, right? sp3 hybridization. Ammonium is tetrahedral, sp3 hybridization, no lone pair. Tetrahedral is the geometry. And lastly, BRF3, the only one thing left out. So you have bromine at the center, and you can see that there are how many lone pairs present in BRF3? 2. You should keep those 2 on equatorial positions only. Then left out geometry is called as T shape. So BRF3 is T shape. So on the whole, you will substitute these values to understand that your answer is option A. Alright, so that formula will really help you. Yes, fantastic, Anish. So lone pairs, when you keep on any other position than equatorial in trigonal bipyramidal structures, it will cause repulsion, like Anish said. So in order to prevent the repulsion, keep the lone pairs in trigonal bipyramidal, especially on equatorial, on the triangle. Don't keep anywhere. In the other structures, keep wherever you want. But only in particular trigonal bipyramidal, you have to keep the lone pair on equatorial. Remember this. Nucleophile is what? Name itself indicate, no? Nucleus, attraction. Philic is all antonym to what? Phobic. Philic means attraction, phobic means fear. Isn't it? So now, positive, nucleus is positively charged. Attracting species, that means what? It is electron rich. Should be a nucleophile. You can see ammonia has a lone pair, OH minus has a lone pair. Both make sense, but you know AlCl3 has an empty orbital, isn't it? You know that it has only 6 electrons in the valence shell, hence is regarded as electron loving, electrophilic. So not brilliant, fantastic. Kya baat? Come on, could you please tell me the answer to this fatafat? Yes, so I'm waiting for your answer, buddy Shreyas. Come on, who else is there active with at Ashley? What's the answer? Come on, go ahead, buddy. What's the answer for this? Ashley says D, daily. Brilliant, super fast answers, Anish. What's the answer, buddy? Methylation would occur, right? Methylation, you know that you will be getting A as methyl benzene, isn't it? Now, when you treat it with KMNO4 in alkaline medium, remember I want to tell you something related to this reaction. Always remember, when you are converting any alkylated benzene into the benzoic acid, you need to understand that the condition is either it should have alpha hydrogen or it should have alpha unsaturation. Alpha hydrogen or alpha unsaturation. If these things are present, no matter how many carbons are present along with benzene, the whole compound will be converted into COOH. Irrespective of number of carbons in the side chain, the whole chunk will be converted into COOH. What is the condition? Alpha hydrogen or unsaturation, not both. Good going, buddies. Can anyone tell me what do you get if I oxidize this by using the same reagent? What do you get, buddies? Cheppandi nana. Waiting for your answers. Come on, speak out, buddies. क्या बनेगा यहाँ पे? कोई तो बोलो. What is the name of that compound which is formed during the reaction? I am waiting for your answers, right? Every second counts here. Anish, Ashley. See, buddies, you know this has the unsaturation. It has a double bond, isn't it? And this has alpha hydrogen. So both of these groups will be converted into COOH, isn't it? Phthalic acid. This is previous NEET question. What is the product obtained? Phthalic acid. Have you understood, Anish? Do you understand what I said exactly? Clear now? However, if your compound has no alpha hydrogen or unsaturation index, for example, you have tertiary butyl, you have, oh, that's okay. I understand. Phthalic acid is the name of compound, but you know the answer, isn't it, Anish? Whereas if the compound has no alpha hydrogen, it doesn't have any alpha hydrogen here, you can make out, right? You can see this is the carbon. Is not present with any alpha hydrogen, it is present with beta, then this does not undergo any sort of, does not undergo any sort of oxidation. So these are some important points related to that. Now this question, I did not expect, because this question is straight away there in your intermediate textbook. That means 12th ka textbook NCERT mein hai, as well as it is there in your board textbooks. Most of the board has this. Ethylene glycol is given. They have even mentioned the molar mass of ethylene glycol. It's a simple question based on the depression of freezing point. And when you talk about the ethylene glycol, is it electrolytic or non-electrolytic? Does it undergo any association or dissociation, or it is non-electrolytic? Can anyone answer this? Because nothing is mentioned, you should take it as what? Non-electrolytic, and Van 't Hoff factor is 1. Alright. In NEET, mostly the questions are straight, so don't twist the concept within your mind and try to commit a mistake. Here nothing is mentioned about ethylene glycol, so take the Van 't Hoff factor as 1 unless they mention. So delta TF, that is TF naught minus TF, equal to I value is 1 KF into, straight away substitute this, mass of ethylene glycol is asked, and you can see that delta TF is 24, straight away equal to KF value would be given into mass of ethylene glycol by molar mass gives you the number of moles of solute, by mass of solvent in kg you can say 18.6 grams of this thing is given. So they will always give in such a way that these things get cancelled. Have you seen these things getting cancelled 0.1 times? Calculations won't be very hectic here. Calculations will be easy. So you can find out the weight of the substance. Calculation, yes Anish. Come on, need an answer for this. How do you predict? Except for hydrogen atom, there is an energy order which we follow. Hydrogen case you will count degeneracy, but other elements you will not count that. And what is the answer for this question? Come on, I am waiting. You guys are giving brilliant answers, absolutely brilliant answers. Kya hoga? 2-3 students are responding really good. I want that tempo to be continued. Come on, you guys are suppressing, depressing, oppressing the entire chat by your brilliant answers. That's the spirit. Come on, go ahead, tell me what is the answer. C. How would you calculate this? It is purely based on N plus L rule, right? More the N plus L, more is the energy. If N plus L there is a tie-up, you will go by N, isn't it? So you can see that first of all N plus L value seems to be greater for these two. So obviously D would be greater. So these two options are naturally ruled out. And after that you are going to check what? N plus L value only, no? So this is after that N plus L tie, you can see between B and C there is a tie-up between N plus L. N plus L is same for both. Then in that case whichever has more N would be taken as a standard reference. Euler diagram. Someone said D, Arya. D hai kya? Maybe D. Yes, D, B, then what? C, 3 plus 1. Correct only. Yes, D, B, C. Okay. Next, stoichiometry questions. Can we solve easily? What is 5 moles of a hydrocarbon undergo complete combustion to requires 5 moles of oxygen and produces 4 moles of water. What is the molecular formula? Let me tell you how simply we can solve this question without complicating it. Listen now. You have got the hydrocarbon. I will assume it as CXHY. Whenever you are given the hydrocarbon, please imagine that as CXHY. And you see you are balancing this by Burning this by taking oxygen, you are getting what? Carbon dioxide and water. First you write the equation, listen to me carefully. If you are applying mole concept, first you write the equation, then you balance it. Let's balance. You can see here, there are x moles of carbon this side, I will write x here. Alright. There are y moles of hydrogen here, 2 hydrogens here, I will write y by 2. Oxygens are how many? 2x plus y by 2. So you have already 2 here, x plus y by 4. That's all. First you have to balance it. Now listen buddies, come on, focus. Chinni, concentrate. You took 1 mole of a hydrocarbon, right? How much? 1 mole. Now this is completely burnt, completely combusted. 1 mole of hydrocarbon gives how many moles of water? Y by 2, isn't it? You can see the ratio. 1 mole gives rise to y by 2. So number of moles of water formed is y by 2, which is given to us in the question as 4. Can you see that? 4 moles of water is obtained. Therefore, you got the value of what? Y as 8. You can see only option which is tallying with this is nothing but C3H8. Can you see buddies? Can you see this? No, need not do the entire question, need not see what's happening to what you call the x part. You can do it straight away without even checking the x value. You can easily do that. If you want to check for x, you can check. You can see 1 mole is reacting with x plus y by 4. So if you have taken 1 mole, the number of moles of oxygen is x plus y by 4, whose value is given to as 5. Now you substitute the value of what you call y as 8. You can see when I substitute here, plus y as 8 by 4 equal to 5, that is x equal to 3, that you can anyways predict, but without finding the value of x, you got the answer. Yes, brilliant. This is how we will get 650. Smart work, like you said. You can see here something is happening, all right. See, can anyone solve this question? Can anyone tell me, buddy, Anish and Ashley, listen to me, this is very important, getting very important. Can anybody tell me without solving this question, what is the answer to this question? Yes, Anish gave the answer. Could you please tell me what made you say D? I want to hear the shortcut to the solution instead of doing the whole stuff. What made you say D? Yes, you are right, absolutely, but what made you say D without solving it? This is what is important at the last stage of your preparation, isn't it, buddies? Can anyone suggest me something? I'm waiting for your answers. FX stoichiometry, FX power, brilliant. Listen now, what's happening? Of course, we are going to do the whole question solution I'm going to give you, but you should know how can I solve this question, this type of question without doing much of the calculation. Listen now. You can see you have been asked to find the equilibrium constant for the following reaction would be, and that reaction is like, you know, NO2. Starts from NO2 is in equilibrium with half N2 and half O2. You guys can see. However, in the given equation for which the equilibrium constant is given as K2, the number of moles of stoichiometry you can see is 2, and here NO2 for the same substance. For the same substance, yes, brilliant. For the same substance, you are given number of moles as 2, whose equilibrium constant is K2, and for the net equation, there is only 1 mole of NO2. You know that when you are multiplying with any factor, when you are multiplying any equilibrium with any factor, and that factor will become rise to the power of the equilibrium constant. Whenever you are multiplying any equilibrium by any factor, that factor will become the power of the equilibrium constant. You can see, in order to get this into this, I am multiplying this whole equation by half. If I multiply that by half, this 2 gets cancelled. So equilibrium constant becomes that power, half K2 power. You can see this is the only option which is satisfying this condition, isn't it? Yes, law of mass action. This is the only equation which is what you call like that, which is fulfilling or catering the demand. Have you understood? So that's why without doing this question you can tell the answer. Now how would we get the answer to that question is take that equilibrium. You can see N2 plus, you can see, isn't it, N2 plus O2 giving rise to 2NO. Alright, but we need only 1 mole. So what do I write? Half N2 plus half O2 giving rise to NO. The equilibrium constant will become K1 power 1 by 2. Isn't it? Whenever I am multiplying with any factor, it will become power of. You can see I am multiplying this whole equation by half. So it will become power of. Isn't it? Now I will take the second equation and I will multiply this by half as well. NO, multiply this by half. You can see here 2 by 2, that is equal to 1, plus half O2 is in equilibrium with NO2. It will become what? K2 power 1 by 2 as well. Now from these two equations you have to get this resultant equation. How would you get that? It's very simple, isn't it? You can see in the net equation. In the net equation you should have NO2 at the product size. Now when you are adding these two equations, your NO is gone. You can see in the net equation there is no NO. First of all you write the net equation. What do you get? Half N2 plus half is 1, giving rise to NO2 equilibrium constant. When you are adding up, it will become what you call the product, and what is asked you is reverse. You can say reverse means the equilibrium constant will be inverted. So brilliant. That's good. Come on, Shreyas and Yasu. I wish you listen, I wish you understand, I wish you study, I wish you give good response as well, right? You wish I teach, I am doing that. You can see that cell potential of mercury cell remain constant during its life. It's a brilliant point, right? Now this has got nothing to do with the change in concentration of any of the active component, Chinni. Come on, could you please tell me the reaction that is occurring inside the mercury cell? Can anyone tell me what happens inside the mercury cell? Important, zinc plus HgO converting into ZnO plus Hg. You see, in this cell reaction, none of the substance is anything other than liquid or solid. You know that when you take a reaction in which there is nothing is solution or a gas, EMF is independent on the concentration, because concentration of the solid or liquid is conventionally taken as 1. Therefore, EMF, you can't write the EMF other than it is depending on the value of E0, because minus 0.06 by N, law of concentration of product by reactant. Concentration of products are 1 because solids and liquids are present. Concentration of reactant is also equal to 1 because solids are only present. So it's constant. It's absolutely correct. Mercury cell is constant. The overall reaction does not involve any ion in the solution. That's the reason. So answer should be correct explanation. That is option A. Brilliant, Anish. Number of electrons. This is basic question. Absolutely basics. Oxide ion has total. Each oxide has 10 electrons. And you know number of oxide ions is mass by atomic mass into Avogadro number into 10. So total is turning out to be, alright, absolutely easy, basic question. Among the following disproportionation, another simple question. Disproportionation reactions are those in which same element undergo oxidation and reduction. Same element undergo oxidation and reduction. For that you need to check the oxidation states of the elements. What is the answer for this? Ashley. Here it is plus 3, plus 5 and minus 3. So plus 3 to plus 5 oxidation, plus 3 to minus 3 reduction. So it is yes, disproportionation. Plus 7 to plus 6 and plus 4, that means reduction. Oxygen minus 2 to 0, oxidation. Different elements are undergoing redox reactions. It is not the same element. So this is not disproportionation. So this should be the right answer. Check the remaining also. 0 to minus 1, 0 to plus 5. Same element is reduced and oxidized. Yes, this is disproportionation. Nitrogen here is plus 3 to plus 5 oxidation and plus 3 to plus 2 reduction. So it is also disproportionation. Which of the following is okay? Is KMnO4 undergoing thermal decomposition? Yes, what is the answer to this? How would you predict what are the what you call monomeric unit that you get? Alright, so you do the whenever you are given a disaccharide, listen to me. What you guys do in all such cases, I am suggesting you something. Listen, Anish, this is important for you. You do the hydrolysis, alright, and check the monosaccharide units. This is in your NCERT textbook. It is there in your textbook directly, Anish. So you can see lactose gives rise to glucose and galactose upon hydrolysis. Cellulose gives rise to beta D plus glucose units, not alpha D plus glucose. Maltose only gives rise to alpha D plus monomeric units. You know, sucrose gives rise to what? Alpha D plus glucose and fructose. So which of the following is said to be having or made of two alpha D plus glucose units? That's not a minus actually. Answer is maltose. Important NCERT textbook based question. Ionic is purely based on Fajan rule, right? Fajan. Some people pronounce it as Fajan. Okay, that's how you made a mnemonic. Brilliant. Now somebody is asking you, a pro is asking how, what is that mnemonic? Come on, speak out. Here, while predicting the ionic nature, listen now. Of a cation, less positive charge, more size. If you are talking about a cation, you can see anion is common, and when it comes to the charge is common. More size is more ionic. Alright, less size is more covalent. So this is lithium is least sized, so more covalent. That means least ionic. Brilliant. Brilliant, buddy. Big cation, small anion for covalent. Is it? Yeah, that's what. Okay, good. This is fundamental question, right? You know, whichever has more oxidation potential. You can see oxidation potential given. Check that carefully. So that will act as the anode. So you should write the cell reaction. Actually, we need not write, but I am telling you so that you can understand. So zinc undergo oxidation. Iron undergoes reduction. So this is the cell reaction. One thing. And when you write EMF, not EMF actually, E naught equal to oxidation potential of anode minus oxidation potential of cathode, if you are writing in terms of oxidation potential. If you are writing in terms of reduction potential, cathode minus anode. Remember. So higher minus lower. Easy question. Plus 0.32. Yeah, that's okay, but still you guys are giving brilliant answers, right, buddies? Good. Glucose, you can't expect anything easier than this, right? This is one of the easiest questions that is asked in the recent times on carbohydrates. This is your glucose, and this upon oxidation gives rise to mild oxidation. Bromine water is a mild oxidizing agent. Remember, HNO3 will oxidize this and this. All right. Gluconic, you will get gluconic means only CHO, aldehyde, which will be easily oxidized, will be oxidized. Whereas if I am taking HNO3, which is a strong oxidizing agent, you will be getting glutaric acid. That means this also will go. Remember this, very important, isn't it? I see everybody is interested in knowing about Anish because you are giving good answers. So please keep doing this until your exam gets over. After that, who cares? Neither I am being cared about nor you. So this is the time, buddy. Make the best use. The star of the day. Maximum hyperconjugation effect. Hyperconjugation always predicted by alpha hydrogens. You can see alpha, right? Something attached to benzene adjacent to the functional group is called as alpha. This is alpha. Whichever has more alpha hydrogens. So 3, 2, 1, 0. So whichever has more, don't count them, they are beta. Count only this which is attached to the benzene, right? 9 alpha hydrogens on tertiary. You made a mistake, buddy. That's wrong, Anish. You are getting lost with your temperament, isn't it? Long-term hunger. But have you seen that there is a scope of silly mistake? See, you would have been correct if your tertiary butyl is attached to what you call any carbocation, any alkene. This is your answer. Because in that case, that is not the point of reference. Here the reference is benzene ring. To benzene alpha, you need to see. Everybody committed this mistake, buddy. Yes. Beautiful question. Dibal. What is dibal? By the way, di-iso-butyl aluminum hydride. It is something like lithium aluminum hydride, but very selective and mild. That's all. Mild reducing agent. Di-isobutyl, you know, isn't it? This is isobutyl. Isobutyl di-aluminum hydride is specific for the conversion of what? Esters, carboxylic acids into aldehydes. So what will happen first is that this water will convert this C into CONH2, partial hydrolysis of cyanides gives rise to what? Amides. Later on, these groups will be reduced. So remember, carboxylic acids derivatives, that is acid halide, ester, amides and hydrides, are reduced to the aldehyde by using dibal. Yes, you should know that. Yes. Brilliant answering, buddies. Brilliant. Hydride group with higher gear. Remember, if you are talking in a group, easy questions. Always remember, buddies. Hydrides in a group is directly proportional, inversely proportional to what? Size. More the size, more is, in case of hydrides, more the size, more is acidic strength. In a group, remember this, in a group, buddies. What I mean to say, that HF, HCl, HBr and HI, whichever is bigger is more acidic. H2O, H2S, H2SC, H2TE. Because in the oxygen group, tellurium is bigger one, therefore the right answer is H2TE. Good. Because higher the acidic strength, higher is Ka. Nomenclature question. Easy, isn't it? Priority order that you have studied. Sulfonic acids are the king of acids among all organic acids. Therefore, sulfonic acids are given more priority, but you can see bloody you are given what you call 3-4 options like that, right? After that, depending upon the reactivity, I think, yes, depending upon reactivity, acid halide comes. So if you can make out that acid halide is more, how would I know that? It is purely based on what? Reactivity of acid halide is greater among all the derivatives of the carboxylic acid, isn't it? You know that acid halides, then comes anhydrides, then comes esters, and then amides, right? This is the reactivity order. So accordingly you have to remember acid halides are more than amides. What do you call this reaction as? If you take NaOH, you will get first O minus, which will attack on this electrophilic substitution, ortho-para-directing, you will get OH, COOH. Remember, if you take NaOH, you will get ortho as major product. If you take KOH, you will get para as major product. Remember this, don't commit a mistake, buddies. If NaOH is present as catalyst, salicylic acid is major product. This is called as salicylic acid. This is para-hydroxybenzoic acid. So if you take NaOH, remember this very important point. NaOH gives you ortho as major product because of chelation reasons that we are not going to talk here. फर्स्ट क्वेश्चन समझा दो भाई पंडित जी. देखता हूँ पहला क्वेश्चन कौन सा, वो कौन सा जो सॉल्युबिलिटी का था. ठीक है, यस, दिस इज SMID. In some books it is also given as Kolbe SMID. ऑलराइट, ठीक है, मैं समझाता हूँ. ये खत्म होने के बाद फर्स्ट हम लोग पिक करेंगे. यू कैन सी दैट द आंसर इज दिस थिंग. होमोलेप्टिक वी डिस्कस्ड, सेम लिगैंड. You can see ammonia and chlorine, only ammonia and chlorine, So homoleptic, that means all ligands of same type, square bracket के अंदर जो भी है, जितने भी हैं, एक जैसे हैं. Easy question. It's called Kolbe-SMID, buddy. Acidic dehydration, that means removal of water. You see, when I am removing water, you should see two things. One is stability of the carbocation. You see, when I put a positive charge here, what do you get? You'll get this. This is very stable because of extended conjugation कहते हैं इसको. What do you call that, buddies? Extended conjugation. That means two pi bonds are helping this positive charge to get stability. This won't come out OH because you know phenolic OH is tightly held by virtue of resonance. It won't come. So this should be least. This is just allylic. Yes, interested to participate in the dehydration. This is normal 2 degree carbocation. So formation of carbocation on the basis, we can say that this is more and this is least. C and D, most and highest is C, least is D. So you can say that as the answer. And moreover, you see when you are writing the product over here, isko nikal do, when you remove that, you see you are getting aromatic compound, the most stable one. You got it. Brilliant. All right. So you wanted me to discuss the first question. देखता हूँ मैं कौन सा है वो. Let me go back to that question after the popular demand from Pandit ji. He came back and asking me there is something fishy. Chalo, let's see. Let's see, buddy. ठीक है, कैल्शियम हाइड्रोक्साइड की सॉल्युबिलिटी दिया है और उसका सॉल्युबिलिटी प्रोडक्ट पूछ रहे हैं. तो किसी भी सॉल्ट का अगर सॉल्युबिलिटी देते हैं तो हम लोग मानते हैं उसको कि दैट इज डिसोसिएटिंग इनटू द आयंस पार्शियली. फिर उसके बाद हम उसकी सॉल्युबिलिटी लिखते हैं कि इसका S मोल पर लीटर पानी में जा रहा है. See, solubility is the number of moles of the salt that goes into the water. If it is soluble salt, अगर वो पूरा पानी में डिजॉल्व होता है तो जितना सॉल्ट आप लेंगे that whole thing will go into the water as ions. अगर आप insoluble salt लेते हैं तो पूरा की तो पूरा नहीं जाएगा, उसका कुछ हिस्सा जाएगा, उसी को हम लोग solubility कहते हैं. जैसे हम लिखते हैं वीक एसिड डिसोसिएशन में C × 1 - अल्फा C अल्फा करके लिखते हैं. स्ट्रॉन्ग एसिड डिसोसिएशन में C00 करके लिखते हैं. तो पूरी तरीके से डिसोसिएट नहीं कर रहा है, जितना डिसोसिएट कर रहा है उसको हम लोग कहते हैं S. तो इसका 1 मोल दे रहा है तो इसका S मोल पानी में चला गया तो ये S बनेगा और ये 2S. ठीक है भाई, समझ रहे हैं ना आप? ओके. सो इसका जो KSP होगा that is equal to what? Concentration of the product by reactant. और reactant का concentration 1 होगा because ये solid है. तो KSP निकालने के लिए बोल रहे हैं तो S × 2S होल स्क्वायर. CaOH टेकन ट्वाइस, अगर मैंने कुछ गलत नहीं लिखा तो 4S³. तो ये आएगा 4 × S का वैल्यू जो दिया है सॉल्युबिलिटी का शायद √3 है. ठीक है भाई, तो ये आएगा, आप ऐसे लिख लो 4 × √3 × √3 × √3 करके लिखो. अब √3 × √3 तो 3 होता है, 3 × 4 तो 12, 12√3 आंसर हो जाएगा. ठीक है, शायद आपको समझ में आ गया होगा. ठीक है भाई पंडित जी, फिर मिलते हैं. ठीक है, वी विल मीट अगेन इन दी नेक्स्ट सेशन. होप यू गाइस हैड गुड लर्निंग टाइम एंड एक्सपीरियंस. प्लीज कीप वॉचिंग. ऑलराइट, thank you very much.